This video is on hyperbolas. A hyperbola is the set of points in a plane whose distances to two fixed points in the plane, the foci, have a constant difference. Recall also that a hyperbola is the shape that you get when you take a double cone and it's intersected by a plane that's perpendicular to the bases and goes through the bases. So the hyperbola has two parts to it right here. So here's a diagram, and I'll go through all of the different parts here. So even though there are a whole lot of lines going on here, the only parts that's actually the parabola is this kind of dark blue curve right here on the right and this dark blue curve over here on the left. Unlike the graphs of the other conic sections, a hyperbola has the two separate curves, and each curve has a vertex. So you can identify what of all of these lines is actually the hyperbola by identifying the vertices. So let's go through some of these parts here. The segment connecting the two vertices is called the transverse axis. So that would be this orange line here. The midpoint of the transverse axis is going to be the center. And then inside the bowl of each curve of the hyperbola is the focus. Perpendicular to the transverse axis is the conjugate axis. Its endpoints are the covertices. So here this light blue line is the conjugate axis and its endpoints are the covertices. You'll notice that the transverse axis and the conjugate axis create this rectangle, which is not actually a part of the hyperbola but helps us to draw it. Hyperbolas also have asymptotes, and those are lines that go through the vertices of this rectangle. Recall that an asymptote is a line that a curve approaches but never touches. So as you're drawing the hyperbola, when you draw this piece here, it approaches that asymptote in the upper right corner, and then it approaches the asymptote down here to the lower right. And as with ellipses and parabolas, a hyperbola can either be horizontal or vertical. If it's horizontal, it's opening to the left and the right, opening on kind of the x-axis in the x-axis direction. If it's vertical, it's going to be opening up and down kind of in the y-axis direction. Standard form of the equation of a hyperbola is similar to that of an ellipse, but you'll notice that it has a minus in the middle here. So the quantity x minus h squared over a squared minus the quantity y minus k squared over b squared equals 1 if it's horizontal. If it's vertical, y squared minus k squared over a squared minus the quantity x minus h squared over b squared is equal to 1. And again, hk is going to be the center. A is the distance from the center to a vertex. B is the distance from a center to a covertex, very similar as to an ellipse. But in this case, C is defined as the square root of a squared minus b squared, and C is the distance from the center to a focus. Notice that when x is over a, the hyperbola is horizontal and opens on the x-axis. So when x is over a, it opens up more on the x-axis like this. When y is over a, it's going to open up and down more in the direction of the y-axis. So let's take a look at a couple examples here. We need to write the equation of a hyperbola that has vertices at 0, 2, and 6, 2, and covertices at 3, 0, and 3, 4. So let's go ahead and do a little sketch. So I'm noticing that my vertices lie on the line y equals 2. So that means that my transverse axis is going to be horizontal. So I know that my hyperbola is going to open like this. So let's go ahead and label those points. So there's a vertex at 0, 2. And then I would have another vertex over here at the point 6, 2. Notice those are on the line y equals 2. My y coordinates are the same. The only thing that changes are my x coordinates. So then my covertices are going to be at the point, this is going to be a covertex at 3, 4. And this is going to be a covertex at the point 3, 0. Notice that the x-coordinates are the same, so these lie on the line x equals 3, and the only thing that's different are my y coordinates. So from that, I can tell that the center is going to be this point here. So my center is going to be the point 3, 2. So that means that h is equal to 3, k is equal to 2. This distance here is going to be a, and that's 3 units. This distance here from a covertex to the center is going to be b, and that's 2 units. And I don't need c. I think I have all the information I need. So since this is going to be opening up more horizontal, my equation is going to be x minus h squared over a squared minus y minus k squared over b squared equals 1. So x minus 3 squared over a squared, which is going to be 9, minus y minus 2 squared over b squared, which is going to give me 4, equals 1. So that's the equation of a hyperbola that has vertices at 0, 2, and 6, 2, and covertices at 3, 0, and 3, 4. And our last example here says, write the equation of the hyperbola 4x squared minus 9y squared minus 16x minus 18y minus 29 equals 0 in standard form. You'll notice that that's written in general form. We need to identify its center, foci, vertices, covertices, the lengths of the transverse and conjugate axes, and the equations of the asymptotes. Then graph the hyperbola. And actually, as I did with some of the other conics that we've done, I'm going to be graphing it as we go along. But let's start by turning this into standard form. So I'm going to group together my x terms, group together my y terms, and move my constant to the other side of the equal sign. I'm going to complete the square for x and y, and in order to do that, I need to factor out my coefficient of x squared and y squared. Now be careful when I'm factoring out a negative 9. That's going to leave me with a positive 2y. And then completing the square, I will add a 4. But I didn't really add a 4. I really added 4 times 4, which is 16. So I need to add a 16 on this side. Here I'm going to add a 1, but I'm not really adding a 1. I'm really adding a negative 9, so I need to subtract 9 on that side. Now let's go ahead and factor this. Oops, forgot the 9. And factor this. And 29 plus 16 minus 9 gives me 36. And since the equation has to equal 1, I'm going to divide everything by 36. Let me move this down a little bit here. Oops. So that's going to give me x minus 2 squared over 9 minus y plus 1 squared over 4 is equal to 1. So there's my equation in standard form, which is going to be very helpful because now I can identify my center, which is going to be equal to 2, negative 1. And I notice that x comes first. X is over a. So a is going to be equal to 3. B is going to be equal to 2. I know that my hyperbola is going to open left-right. It's going to open like that on the x-axis. Let's go ahead and find c. So c is equal to the square root of a squared plus b squared, which is the square root of 13, which I'm just going to leave like that. So that's going to be somewhere between 3 and 4. Square root of 9 is 3, square root of 16 is 4, so somewhere between 3 and 4, just so I kind of have an idea of what that is. Let's go ahead and start graphing. So 2, -1 is my center, and I know that it's going to open left, right, so my vertices are going to be A units to the left, or to the right, A units to the left. Okay, center, oops, vertex, vertex, co-vertices, up 2 and down 2, and I'm going to go ahead and write those before I lose track and start drawing more stuff. So I'm going to have vertices at 5, -1, and -1, -1, co-vertices at 2, 1, and 2, -3. Okay, I'm going to go ahead and draw the rectangle, draw the box. Now remember, this is not actually a part of the hyperbola, but it helps us to draw the hyperbola, because in order to draw the shape, I need to have the asymptotes, and the asymptotes are going to be the diagonals of this rectangle. So I'm going to go ahead and draw my asymptotes here, going from the center out to the vertex of each rectangle, each vertex of the rectangle. Okay, and now I can actually draw my hyperbola. So from this vertex, it's going to go out towards the asymptote. Probably should be a little more curved than that, but that's the idea. So that's actually my hyperbola right there, those two curved parts that open to the right and to the left. What else do I need? I need to find the coordinates of my foci. And my foci are going to be points inside the bowl, so they're actually going to be further out here, one of them out here and one of them out here. So from the center here, it's going to be square root of 13 units this way. So I said that's somewhere between 3 and 4. So I'm going to have a focus somewhere right about there and a focus somewhere right about there. So notice that those lie on the line y equals -1. So the only thing that's changing is the x coordinate. So I can do this, 2 plus or minus the square root of 13, comma, -1. Now what does that mean? That means that from this x coordinate of the center, notice the x coordinate of the center is 2, I went square root of 13 units to the right, so that's plus square root of 13, and then I went square root of 13 units to the left, that's minus square root of 13. So this is actually the two x coordinates of the foci, 2 plus square root of 13, 2 minus square root of 13, and then my y coordinate stays the same, -1, since it's on that line y equals -1. My transverse axis, which is my longer axis between the two vertices, is 6 units long. My conjugate axis, which is between the co-vertices here, is going to be 4 units long. And the last thing I need to do is find the equations of the asymptotes, these two diagonal lines right here. So it's actually pretty easy. I can just look and I can tell that the slope of this one is going to be up 2 and right 3. So I'm going to have a slope of 2/3 for one of them, and the other is going to be down 2 and right 3. So my slopes are going to be plus or minus 2/3. But looking at the graph, my y-intercepts are not going to be nice integers. It kind of looks like it might be 0 here, but I'm not sure. So I can actually say that the equation of my asymptotes, I'm going to use point slope form. I'm going to say y. Now, do I have a point on both of those lines? Indeed, I do, the center. So the center, 2, -1, is actually a point that lies on both of those lines. So I can use that. So y minus y1 is equal to m, and I'm going to use the slope, plus or minus 2/3, x minus 2. So those are the equations of the asymptotes. I'm going to leave them in point slope form and not put them into slope intercept form. And then here's all of the information I was looking for on my hyperbola. So hyperbola is probably the most complicated of all of the conic sections we've taken a look at. But I think a combination of knowing certain aspects of the hyperbola and graphing it as you go along and kind of figuring things out as you're graphing is going to be very helpful. So in this video we took a look at what a hyperbola is by definition, what all of its parts are, and how to write an equation given the vertices and the covertices, and how to take an equation that's in general form, turn it into standard form, graph it, and find all of its relevant parts.